You're flying over mountains. Then suddenly you're being chased. Then you're back at school, and there's an exam you never studied for. Then you wake up. The dream is gone. Almost all of it, gone within seconds. Every single night, your brain puts on a private show just for you. But why? What is actually happening? And does it mean anything? Science has answers, and they're stranger than any dream. First, let's understand when dreaming happens.
Your sleep runs in cycles of roughly 90 minutes each, cycling between NREM and REM sleep. While you can dream in any stage, dreams are most vivid and story-like during REM sleep, rapid eye movement sleep, where brain activity spikes to levels that rival being fully awake. During REM sleep, several key brain regions activate simultaneously. The amygdala, your emotional center, fires intensely, which is why dreams feel so emotionally charged. The hippocampus, your memory hub, replays and shuffles memories. The visual cortex generates vivid imagery, even with eyes closed. But here's the crucial part. The prefrontal cortex, the region responsible for logic, planning, and critical thinking, goes nearly dark. This is exactly why you can fly, talk to dead relatives, and walk into a building that is somehow also your childhood home. And it all feels completely normal. Without logic running, anything goes. Now for the big question. Scientists don't have one single answer, but they have 4 well-supported theories, each backed by real evidence. Let's go through them. Theory 1, memory consolidation. While you sleep, your brain is not resting. It's doing maintenance. Recent memories from the day are replayed, sorted, and either filed into long-term storage or discarded. Research from NIH and multiple neuroscience labs shows that the brain literally replays patterns of neural activity from recent learning during sleep.
Dreams may be the conscious side effect of this filing process, fragments of memories surfacing as the brain shuffles through them. A 2025 study published in Nature Scientific Sleep describes dreaming as a byproduct of sleep-based memory consolidation, where a narrative is constructed around memory fragments being processed. Theory 2, emotional processing. UC Berkeley researcher Matthew Walker and others propose that REM sleep acts as a kind of overnight therapy session.
During dreaming, the brain replays emotionally charged memories, but in a neurochemical environment with reduced levels of norepinephrine, the brain's stress chemical. This allows you to re-experience and process difficult emotions without the full biological stress response. Studies show that REM sleep and dreaming help transform emotional memories, reducing their intensity while preserving the lesson. People deprived of REM sleep show significantly impaired emotional regulation the next day.
Theory 3, threat simulation. This evolutionary theory, developed by Finnish neuroscientist Antti Revonsuo, proposes that dreaming evolved as a biological rehearsal system. By simulating threatening scenarios in the safe environment of sleep, the brain trains your threat perception and survival responses. Supporting this, research shows that 66% of recurring dreams contain at least one threatening event.
The 2 most commonly reported nightmares across cultures are being chased and falling, both classic survival threats. Your brain is essentially running drills while you sleep. Theory 4, activation synthesis. Proposed by Harvard psychiatrists Hobson and McCarley, this theory suggests that during REM sleep, the brainstem fires random electrical signals, called PGO waves, upward into the cortex. The brain, being a pattern-making machine,
automatically tries to construct a coherent story from this noise. The result? A dream. Most current neuroscientists consider this a partial explanation. The randomness is real, but the brain's choice of which memories to weave into the narrative is not random at all. Before we get to lucid dreaming,
here are 5 things about dreams that science has actually verified. 1. You have between 3 and 6 dreams every single night, each lasting between 5 and 20 minutes. You're dreaming for roughly 2 hours every night, whether you remember it or not. 2. Approximately 95% of dreams are forgotten by the time you get out of bed. Only around 40% of people can recall a dream on any given morning. The brain doesn't prioritize storing dream content. It's already moved on. 3. Most people dream in color. But roughly 12% of people dream entirely in black and white. And interestingly, this percentage was much higher before color television became widespread, suggesting that our media environment influences dream content. 4. Across all cultures studied, the most common dream themes are falling, being chased, and showing up unprepared for a test or exam. These themes appear universally regardless of culture, language, or geography, suggesting they tap into fundamental human anxieties. 5. About 65% of dream content directly mirrors features of your recent waking life. People you've seen, places you've been, problems you've been thinking about.
Your brain doesn't invent from scratch. It remixes reality. Sometimes, a remarkable thing happens mid-dream. You realize you're dreaming. This is called lucid dreaming, and it's been scientifically verified using EEG and eye signal communication since the 1970s. A landmark meta-analysis of 34 studies found that 55% of people have experienced at least one lucid dream in their lifetime, with around 23% experiencing them at least monthly.
What makes lucid dreaming neurologically unique is that during these experiences, the prefrontal cortex partially reactivates. The logical part of the brain that went dark during regular REM sleep switches back on just enough for you to recognize, wait, this isn't real. Studies from Nature Scientific reports show increased functional connectivity between the frontopolar cortex and parietal areas in frequent lucid dreamers. So, why do we dream?
The honest scientific answer is probably all of the above, working together. Memory consolidation, emotional processing, threat simulation, and random neural activation are not competing explanations. They're overlapping functions of the same complex system. Dreams are your brain doing maintenance, therapy, training, and storytelling all at once. And the fact that 95% of it evaporates the moment you wake up, that might not be a flaw.
Your brain may have decided that most of what it processed overnight simply doesn't need to make it into your waking memory. It did its job, quietly, while you slept. So tonight, when the show starts, let it run.